Uh, Myself, Dr. S P Mishra, from Professor, Department of Civil Engineering, BIT Durg. I'm going to present a lecture on repair and rehabilitation of structures. Repair and rehabilitation of RCC buildings. Introduction. Here we are covering the need buildings and other structures have a certain useful life which depends on the specification adopted. The large number of monuments and other cherished heritage structures have stood well over a period of time, but some of these have shown sign of distress due to age, aggressive natural environment, industrial pollution, etc. Distress get aggravated due to overloading, misuse of buildings. A few buildings have also failed due to faulty design and or construction. Construction is generally expected to give trouble-free service. Concrete construction is generally expected to give trouble-free service throughout its intended life. However, these expectations are not realized in many construction because of structural deficiency, material deterioration, unanticipated overloadings, or physical damage. Premature material deterioration can arise mainly when the construction specifications are violated or when the facility is exposed to harsher service environment than those expected during the planning and design stages. Physical damages can also arise from fire, explosion, or as well as from restraints, both internal and external, against structural movement. Except in extreme cases, most of the structure require restoration to meet the functional requirements by appropriate repair techniques. Construction documents contain adequate specifications. Standard cube test results are taken as a measure of quality of the construction, whereas factors as a method of placing, compaction, and curing of concrete, which have significant influence on the quality achieved in the hardened concrete, are scant attention. Many at times, the quality of concrete as placed and hardened in position has no correction to the correlation with the cube test results. Procedures mandatory or otherwise for periodic inspection of buildings and structure and documents defects like cracks, excessive deflections, corrosion of reinforcement, etc., and recording of structural repair already carried out are generally not followed or maintained. In some buildings, only visual inspection is carried out for preparing maintenance budget estimates, and this exercise is often left to the engineers who have no experience in such problems. A comprehensive inspection data helps in making an effective strategy for repair and rehabilitation. Non-destructive evaluation of concrete are very good tools for establishing quality levels in new construction. It is important to select the appropriate non-destructive evaluation techniques. On the most difficult problem is repairing a reinforced concrete element is to handle corrosion damage. Reinforced corrosion causes by carbonation. Repair reinforcement corrosion involves a number of steps, namely removal of carbonated concrete, cleaning of reinforcement, application of protection coat, making good the reduced steel area, applying bond coat and cover replacement. When chlorides have entered through materials used in construction and residing in the hardened concrete, it is extremely difficult to protect reinforcement steel from chloride attack. Repair management. Three distinct stages are to be recognized while taking up a repair job: documentation, preparation of detailed drawings, execution of repair. Execution of repair. Supervising engineers should have a good understanding of the procedure to monitor the effectiveness of repairs by various tests before and after the repair. Selecting a most appropriate material, repair methodology, compatibility of materials, and just as building durable construction require understanding of structural engineering, material science, and environment exposure conditions, repair jobs also require the same level of attention in these areas. Next next topic which related to this is causes of deterioration, causes of deterioration and durability aspects. All concrete in service will be subjected to chemical and physical changes. A durable concrete is one in which these changes occur at a rate which does not determinately affect the performance within its intended life. It has been observed that RCC has not proved to be durable due to large number of factors. We will directly come to this figure. It indicates that concrete is porous but impermeable structure. When we make a concrete, when a new concrete is made porous but impermeable, then it is durable. And when it is porous but permeable material, then it is not durable. It has been observed that RCC has not proved to be durable due to large number of factors including variations in production, loading conditions, service life, and subsequent attack by the environment factors. A well constituted, properly compacted and cured concrete used in RCC concrete continues to be substantially watertight and durable as long as capillary pores and micro cracks in the interior do not become interconnected pathways leading to surface of the concrete. Holistic model of deterioration of RCC. Here we are covering what are the reason, what are the models by which the deterioration of a structure takes place. First is the model 1. According to this holistic model of deterioration of concrete is considered in two ways: due to loading and weathering effects, and during the second stage water, oxygen, carbon dioxide and acidic ions are able to penetrate easily into concrete. See, this is the diagrammatic representation of this model 1 for deterioration. A watertight reinforced concrete structure containing discontinuous cracks, micro cracks and pores is due to the weathering environmental action stage 1, no visual damage appear, but weathering affects cyclic heating, cooling, wetting, drying is continue. Load effects, cyclic loading and impact loading is continue. And due to this, gradual loss of water tightness as cracks, micro cracks and pores become more interconnected. This concrete then attacked by environmental action stage 2. It is initiation and propagation of damage. Penetration of water, penetration of oxygen, carbon dioxide, penetration of acidic ions such as chloride and sulfates from the environment. And this influences, it causes expansion of concrete due to increased hydraulic pressure in pores caused by corrosion of steel. Sulfate attack on cement paste, alkali attack on aggregates, freezing of water, and simultaneously reduction in the strength and stiffness of concrete, which causes ultimately cracking, spalling and loss of mass. And then again, if the concrete structure is because concrete structure is long lasting, then again the structure doesn't fail at this stage, but this is continue, the cycle is continue from the water loss of tightness in the next layer and expansion of the concrete in the next layer and reduction in strength the next layer. Then we come to the model 2, where according to this concept there are 3 stages: gradual loss of water tightness, initiation of damage and propagation of damage. This is shown by figure. This is shown here that this is in y-axis there is a damage shown, and here is the service life in years. And initially at stage 1 the concrete structure get affected by gradual loss of water tightness. In first stage 1. Gradual loss of water tightness is caused, and the cementing material get loosened, and the second stage is initiation of damage. Stage 2 is the initiation of damage at the next stage of service life. Then it's the propagation of damage goes high, and stage 3, and this is causes this is the service life of a structure with an acceptance damage limit D. This is the up to after this here is the service life of a structure with an acceptance damage level D. Here the structure is not falling, but it is continue. It is the acceptable damage limit is shown, but here this part shows the service life of a structure with an acceptable damage limit. Model 3, in this model, the deterioration of concrete is dependent on the important role played by water cement ratio. Model 3 is shown like this. This is the the concrete interconnected porosity, and then damage of reinforcement concrete. This is the presence of water. In the presence of water and aggressive agents, oxygen, carbon dioxide, this causes damage to RCC, and because of the capillary action, macro voids and micro cracks due to loading is caused the service life loss of service life of structure. Then permeability of concrete, as we know, the life of a concrete, the durability of the concrete is depends upon the permeability of the concrete. The permeability of cement paste is a function of water cement ratio, and beyond water cement ratio of 0.55 there is an asymptotic increase. Interconnected porosity is related to capillary porosity, high water cement ratio, inadequate curing, air voids, improper compaction, micro cracks, etc., and macro cracks. Then this is shown the water cement ratio in concrete, and its effect on my work permeability. Then permeability of cement paste is a function of water cement ratio. Here this is in detail discussed. Capillary porosity is discussed here, and here the capillary shows that the capillary increases, it is reduces with the hydration, and it is also reduces with the water cement ratio. This is what here shown. The cement 100% hydration, varying water cement ratio is shown. It is 0.4 and it is 0.7 water cement ratio, and curing time required for various water cement ratios. For this is the curing time required. It should be maintained, and for the life of structure. Typical reduction in permeability of cement paste with progress of hydration is shown the fresh concrete and the days, and this is the coefficient of permeability as it is decreases. Then air voids, also micro cracks, and this is the cyclic loading. This is the this shows the cyclic loading. This is the cracks depths in structural member due to cyclic loading are higher than due to the static load of some same intensity. Figure below explain the crack propagation due to cyclic loading. Then the differential thermal exposure causes the structure life of a structure. It is influenced. This is shown by thermal loading of a structural member. This is ambient temperature during the casting is 27 degrees centigrade, and inside it is this, and winter it is this. 27 degrees centigrade summer, and winter it is 15 degrees centigrade inside, and outside there is this temperature is 70 degrees centigrade and winter 27 degrees centigrade, which causes the thermal contraction to cause tensile stress, because the lower temperature inside and high temperature, this is the thermal loading. Then other causes, aggressive deterioration of chemical agents, carbonation, chlorides, sulfate attack, alkali aggregation, durability aspects, conditions, and here because of the time I'm just finishing my concluding my work that